In this video, we will understand through a graph, just by observing a graph, whether the graph belongs to a function or a relation by a wonderful test called vertical line test. Before understanding this concept, let us first quickly recapitulate what is the meaning of a function and a relation. A function is basically a formula in which a particular input, say for example, a particular x value will result in one and only one value of fx, which is the output. Input is the domain set and output is the range set. So for every domain set element, there is one and only one element in the range set. Such kind of a formula is called a function. Every function is a relation, but every relation need not be a function. It's because in case of a relation, for a particular input, means value of x that is fed into the formula called fx, there can be more than one value or output. That means for a particular input or element in domain set, there can be more than one elements in the range set. Such kind of things are called relation. Remember, when we draw the graph or when we see a graph, every point on x-axis will be related to domain set element, and y-axis numbers elements will be the range set. A quick recapitulation of the discussion. A function is a relation where each input, usually an x value, corresponds to a unique output, usually the value of y. Inputs are actually domain set element. Outputs are actually range set elements. Graphically, this means that if we choose a value of x on the graph, there should be at most one value, one point with that x value, since it corresponds to at most one value of y or one y value. What is vertical line test? It is a wonderful test to identify a given equation or expression is a function or a relation. The vertical line test is a graph of a relation. Graph of a relation is the graph of a function if every vertical line that is drawn through the graph intersects the graph at most once. That means we have a graph and we start drawing vertical lines. If that vertical line intersects the graph in exactly one point, then that graph belongs to a function, or else it belongs to a relation. Let's go ahead. Let's go ahead. Here we are having an example. Determine whether the graph, you see the graph, the red color line, graph of the relation is the graph of function or not. So this graph intersects y-axis at 7. Y-intercept is 7. So equation of this line is y is equal to 7. So it is a linear equation graph because y's exponent is 1 and it is a straight line also. To identify that the graph of this relation is the graph of a function or not, let's draw the vertical lines through this. So I'm drawing the vertical line. So it need not intersect x-axis, but still I'm taking it through. So these are the vertical lines. You can draw wherever. Now let's understand the test. The vertical line intersects the graph in exactly one point. So these are the black dots where the lines intersect. What does this mean? Every element on the x-axis are the elements of domain set. And every element along the y-axis are the elements of range set. So for a particular element in domain set, say for example here x is equal to 3, there is a distinct value of y, that is y is equal to 7. When x is 6, then the value of y is 7. Let me draw the domain set and the range set. Domain set has the values of input, that is x. So here we have x as a 3, x as 6, x as a negative 7. Let's have these three just for an example. And for all these values, the value of y is 7. Value of y is 7. So here we have 7. So the input x is equal to 3, on substituting in the formula called fx, is mapped to 7. 6 is also mapped to 7. Negative 7 is also mapped to 7. That means for every input, there is an exclusive output. Such kind of relations are called a function. Now, in case we want to understand when this function is not, when this relation is not a function, then we have elements 3, 6, negative 7. In case we have some more than one elements here. So the number 3 is mapped to 7, 3 is mapped to 8 also. Maybe number 6. 6 is mapped to 7 and 6 is mapped to 9 also. If this kind of a thing happens, that means for a particular input, you get more than one output, then such kind of formula is a relation. So this is a relation. But in this case, for a particular input, there is a distinct output, one output. That means for 6, the output is 7. For negative 7, it is 7. That means inputs have common output. That is okay for a function. So this is a function. And this is called a linear function, the graph of linear function whose graph you are seeing here. Linear function. Why? Because it's a straight line. Equation of a line, linear. Going forward to the next example, we are given a statement. Determine whether the graph of a circle. So this is circle equation. Equation of a circle, x square plus y square is equal to 9. This is called equation of a circle. Does this represent a function? Function's meaning is for every one input, there is one output. There should not be more than one output. If outputs are more for a particular input, then it is not a function, it is a relation. To identify whether it is a function or relation, of course, every function is a relation. Every relation is not a function. We have to remember that x-axis is the domain set, y-axis is the range set. Now let's do the vertical line test. For the vertical line test, we are drawing vertical lines, that means lines which are parallel to y-axis. Here are few of them. When we have drawn the vertical lines, we have noticed that the vertical line has intersected the circle graph. You see, the first vertical line has intersected the circle graph in 2 points. Second, also intersected in 2 distinct points. Third one, we have drawn just 3 vertical lines to test. Have intersected the graph in 3 points. What did we understand here? Let's do the domain set and do the range set. Domain set elements are what? Say this is 0, it's 1, it's 2, it's 3, negative 1, negative 2, negative 3. So 1 and 2 and negative 2 are the elements through which the vertical lines have passed. So we have domain set elements 1, 2, negative 2 to take few of them as an example. Range set elements are what? So this is 1, 2, 1, 2, and 3. On the other side, negative 1, negative 2, negative 3. So 1 is, this is the coordinate, 1 and 3. So 1 mapped to 3. 2 mapped to 2. This is 2 comma 2. So 2 is mapped to 2. Wonderful. All well till now. Now this 1 is mapped to, 1 is mapped to negative 3. So this is 1 comma negative 3. So 1 is mapped to one more element. See, a particular input is having more than one output, which is the definition of a relation, not the definition of a function. So here the rule is broken. Then we have one more coordinate, that is a 2 and negative 2. So 2 is mapped. So we have few more elements here. 2 is mapped to negative 2. Oh. And let's see what are the other coordinates. Negative 2 and 2. So negative 2 is mapped to 2. And on the other side, we have, this is a point of intersection. Let's think that this is point of negative 2. Negative 2 and negative 2. So negative 2 is mapped to negative 2 also. And did we notice that a particular input, 1 is mapped to 2 of them, 2 is mapped to 2 of them, negative 2 is mapped to 2 of them. So for a particular input, if you have more than one output, such kind of a relation is not a function. It's just a relation and it is not a function, not a function. So there's a wonderful test to identify whether a given relation is a function or not. So it's no, not a function. Let's move ahead. Here we are given the graph of an inequality. So the equation is y less than or equal to x minus 1. Is this a function? Let's do the vertical line test. So I'm drawing some vertical lines. The first one, vertical lines are lines parallel to y-axis. So here is one more. Let me draw one more. So these are the vertical lines. Now, let's see the point of intersection. Vertical line. So the vertical line has, in equation, is not equation of a line. It's the equation of a region. That's why the shading is done. So the domain set elements are along x, range set elements are along y. So let's find out some of the solutions of these of this inequality. One of the solution is 8, 0. One more solution can be 8, 2. Few more can be 8, 5. Let's see the negative direction. 8, negative 8. Let's see something else here. That's negative 8 and negative 9. Let's find out something else here. Negative 3 and negative 5. So we got some of them. So this is 3, 0. And let's see something here. That's 3 and negative 6. Let's draw the domain set, which is the input of a relation, and the range set. What are the elements in the domain set? Everything that you see in the first coordinate. In the coordinates, the first number is the x information, the domain set elements, they are those. So we have here 8, we have here 3, we have here negative 3, negative 8. And the second number in the ordered pair are the elements of the range set. So we have 5, we have 2, we have negative 2. So there is 5, 2, negative 2. We have 0, we have negative 6. We have 0, we have negative 6. Then we have negative 5, we have negative 5. Do we have something else? So many actually, we have chosen a few. Now let's see how the mapping is done. So 8, 5, 8, 5. So 8 input will result in 5 output through the formula called fx. We are only testing that fx is a function or it's not a function, it's just a relation. But 8 is having one more output, that is a 2. So here itself the test failed, like whether the graph of the relation is a function or not. A particular input 8 resulted in more than one output. So here itself, so now we need not check anything else. If one failed, its meaning is it is no more a function, it's a relation. So inequalities are basically not functions. Inequalities are relations. So let's remember through this vertical line test that inequalities cannot be a function. They are relations. They are relations, only relations. For a particular input, there may be, not maybe, there will be more than output because it is a region. A region has many points. Going forward. Here we go. So the question is, does the green curve from the graph in the introduction, that's this introduction of a particular topic, represents a function? Very simple, you have done the vertical lines. So the vertical lines are intersecting the green line in distinct points. And if the intersection point is only one, then it is a function. So it is a function, and every function is a relation. So it is distinctly a function. Is this relation a function? Yes. Now let's quickly check whether the graphs of these functions determine whether graphs of these relations, whether the graph of these relations are graphs of functions also. For that, let's do the vertical line test. For the first one, I'm drawing vertical line. So 1 point of intersection, 1 point of intersection, 1 point. So it's a function. It's a function. Here, vertical line test, distinct point, distinct point. So this is also a function. If you can identify which function is this, because we have just completed the family of function. So you have to identify that. The first one, you can identify based on the number of points in which this, okay, this is a periodic function, by the way. This is a periodic function. This one is a parabolic function, means what? Square function. The next one, if you draw a line, a vertical line, let's see. So this is a point like -1 and 0. And then you have -1 and 1. You have somewhere -1 and 3. So how do you check that if a line is parallel to y-axis is a function or not? So we have elements in the domain set as just -1, but elements on in the range set is 0, 1, 3, okay, -3, etc. So the number 1 is mapped to more than 1 point. So if you have a linear equation graph, that means it's a straight line. It's a straight line. So here it is a straight line. I'm talking about this. Straight line means what? Equation of a line. But the vertical line indicates how many solutions you see. Let me write all the solutions. -1, 0. Then this is -1 and 1. This is -1 and 2. This point is -1 and -1, -1 and 2, -1, -3, all those. So when you do the domain set and do the range set, domain set has only one element. X-axis elements are called domain set. That is only the graph is intersected x-axis at -1. But the line has passed through so many points on y-axis. So that's 1, 2, -1. So that's 1, 2, -1, -2, -3. So 1 is connected or mapped to so many elements, infinitely many elements, because it's a line. In that case, it's not, this graph of a function is not the graph, this graph of a relation is not graph of the function. So that's the conclusion. It's not a function. It's not a function. This one is a function, quadratic function. This is a periodic function like sine. It is sine, of course. Okay, so it's a periodic function, means it is a function. Next one, when you do the vertical line test, you distinctly find the vertical line intersecting the graph in just 1 point. So it is a function. It is a function. Next one, Here it is interesting. When you draw the vertical line, just watch. It has intersected the graph in so many points. So it's not a function, it's just a relation. It's not a function, it's just a relation. Here, if the line is parallel to x-axis, the vertical line test says that the vertical line intersects the line in just one point, indicating that for different values of the input, there is an exclusive value in the range set, that is output. So it's a function. Very clearly, vertical line test tells that if the vertical line intersects the graph in just one point, then it is a function. Here in this case, when we draw vertical line, it has intersected here as well as here. That means for a particular value of input domain set element, there are at least here two. Of course, you'll get throughout two only. So two values of y. That means a particular domain set has two different, it's mapped to two values of y, two outputs for one input. So that's not a function, it's just a relation. It's not a function, but it is a relation. In the next case, vertical line test suggests that for a particular input, there are more than one output. So again, it's not a function. Very quickly, the other one is also not a function. But in this last case, when we draw vertical lines, vertical lines, the vertical lines are intersecting the graph in one point. So it is a function. And if you have identified what kind of function, it is absolute value function, absolute value function. So when you draw a graph of this relation, which will turn out to be a function. I hope this data is useful.